have reached Russ Grease with rwgresearch.com. Open-source-energy.
Hey, what's up everybody? Russ with rwgresearch.com here. Today, this video is about making a Hotend. So currently I'm working on the OSD, and I'm going to be making some of my own Hotends anyway. So I thought I'm going to remake the one on my current printer. It's giving me fits. It's just the regular heating block with the like 10 watt or 5 watt heater with a thermistor through it, and it's really annoying. It drives me nuts. So I modified it already with a liner of PTFE like this, and it seems to be working okay, but it's still giving me fits. So I'm used to having something that I custom built anyway, and originally Jeff built my first Hotend and I liked it so much that I'm going to be making one very similar to it. So I made this entire thing in a different video. You guys can check that out. So what are we going to do? The goals are make it out of PEEK because I actually like it. The regular boring J Hotend from the original riprap actually works really well, and make it a pretty high wattage heater and make it wrap around this guy like this. And then I'm also going to make it so I can thread something into the bottom. It needs to be that way so I can thread a new tip into it without messing everything else up. So that's my goals. I have a bunch of leftovers and stuff here on the bench from some other parts and pieces, and some of this came from George at Georges3Dprinters.com, I believe. I'll link it in there. He sent me some of this pieces and parts from old heaters and components, but the one on my current printer is actually it's a cheap Chinese knockoff, and unfortunately it's just junk. So these are actually, for instance, here is one of those pieces without the Hotend on it. And I really don't like this all-metal Hotend because you absolutely have to blow a fan across here, and I just don't want to. So, I'm not going to. I'm going to be switching back to this old style. So, here we go. Starting with PEEK, P-E-E-K. It's a high-temperature plastic, and this is 0.75 inch OD. Let's get to building. Okay, so starting out, we're going to be making basically what you see here, this bottom component. This is just an aluminum one, but I'm going to go ahead and make one out of the PEEK. And it'll be pretty well identical to this. This is the way the old J Hotends mount, and I like it, and so I'm going to continue with it. And so we're going to make a piece that looks, well, basically just like this out of PEEK. Alright, so we just hacksawed a 1.25 inch piece of this off. We'll clean it up and get it the right diameter. Okay, so there's this little piece. We got threads on this side, a hole on this side. It's basically the same thing as this right here, a little taller because I may shorten that depending on how much I need to take off here. I gotta take the other printer apart and look. I think there's a little bit of stuff there I gotta get out yet, but yeah, that turned out pretty good. There we go. So now we gotta get the and this is only threaded up to a point where I can thread it against there and it stops, so that's it. So we'll cut the end of this bolt off and drill a hole through this, and this is actually going to be our feed through. Okay, so starting out with the end, I've actually got this copper contraption. It's already got threads and holes in there, the wrong size. We'll drill that out and tap it. And then it's got a thing on the back. This is actually a contact that came out of like a big contactor. Something you'd find in a golf cart or something like that. So I'm basically going to take this exact piece, and this is going to thread in so far, and then my Hotend's going to thread in the other way so far, and then I'm going to actually wrap my thermal wire around this guy. So I'm just going to kind of trim this up, drill the hole all the way through, tap it the right size, and see how that turns out for me. Alright, for purposes of getting this thing done, this is what it turned out. Threaded through the center, flat on the end. I could still get something. I'm probably going to cut these edges off so I can get a wrench on here if I needed to. Because I do want to be able to take the tip off, but I don't care about taking the rest of this off. So it's threaded all the way through. M6, by the way. Alright guys, so I decided to go ahead and use my old tube to try this out. It actually has a copper insert, copper sleeve insert, and then what I did was I drilled this out to the diameter of 0.154, and then put this in the lathe and actually pushed the tube in there as it turned. So that gets me a nice compression fitting. So these two pieces need to be fitted like so, and then we'll put the other end on the other side and see how that works out for us. Alright, so here it is. You can see now what I was talking about the little copper insert. So the PTFE goes down somewhere in here, and then there's a little copper insert that's just the right diameter for the filament. This piece is going to go on here like this, and that copper insert is going to allow for the back end of the nozzle to sort of compress onto that and make a good seal. So now we're going to wrap our heating element right here in this section. Hopefully all works. I think I might even try to put the thermistor somewhere right in the middle of this little block right there. Alright, so on my printer the original mount looks like this with the J-head plate that I made. So in this case it fits like this, and I've cut this. You can't really tell, but there's a tiny little slot in there where the PTFE stops, and this whole diameter is actually smaller going through this plastic part. So I made this fit just right, and it clamps like this. I like this easy thread 3D printed threaded thing on the original design. So this clamp like this, that's what actually holds this guy in place, is this clamping mechanism, which this could be better if it was metal. That would really be a better option, but anyway, so the PTFE liner goes all the way down through there. Now there's a little gap in there, you can see, and I probably should fill that in with something, even PTFE tape, just to keep it from doing something silly. Alright, welcome back everybody. It's the next day. I'm inside doing some other things and I got a few minutes. So basically, I'm going to be making the heating element. How am I going to do that exactly? Well, I'm going to be taking this Catenol D wire. This happens to be 24 gauge. I think this is what I used last time. It worked really well. But, I don't remember. I might have used this stuff. So this is also Catenol D. Oh, is it back? It's upside down. No, it was right. There you go. So you can see the diameter, the size, and everything else here. This is a spool I bought off Amazon or something that was on sale. Leftover scraps. I'm going to get it all tangled if I'm not careful. Okay, basically what am I going to be doing? First thing I'm going to do is make sure this doesn't go flying everywhere. Okay, so basically what I have here is I have just a regular 12 volt DC power supply. I was going to use a battery, but oh, there goes the coil. Anyway, okay, so I have this connected to an AC supply, and I've got 12 volts here. So what I'm going to actually do is I'm going to take my amp meter, alright, voltmeter at the moment, 12.05 volts, okay, and I'm basically going to take a length of this wire. I'm going to short it across this power supply and check for how hot it gets, basically. Just visually looking how hot does this wire get. And I'm going to check how much current, and I'm going to just do that for different lengths of wire until I find the right amount of amperage that I know my board can handle, and the right amount of current that I know my wire can handle. And that'll give me basically the maximum wattage without burning the coil or the circuit up. So that's what I'm going to do. Okay, so I've tested the first piece of wire, and I'm just going to go ahead and base it on about 2 amps. So the smaller wire, which I didn't tell you, it is actually 0.1 0.0126 or 0.23 millimeter diameter. And it says here 16.7, well, I don't know what that is, but 5.09 ohms per 1 foot. So we could do the calculation. We're at just over a foot, okay, and we've got about 2 amps, and it's not quite red hot. It's actually just below ambient. You have to hold your hand over it to see it, so that's about comfortable. I don't want it glowing red hot. That could potentially burn the coil out, but yeah, it puts out some serious power. So what I'm going to actually be using besides Kapton tape is this. This is exhaust crack leak stuff, and it turns really hard. It's basically sodium silicate, and this will harden. So I'm going to wrap the coil with Kapton tape to keep it insulated. Then I'm going to wrap the whole thing in this layer on layer, and however I need to do that, and then this will actually be my protectant. Okay, so I did the bigger 24 gauge wire, and I need like over 2.5 feet of this stuff for about 2 amps. I think I actually like this stuff better, but you know, if I had to wrap 2.5 feet around a small object like this, I'm gonna have a lot of wire. So although I could pump more current through this and get it hotter, I think I'm going to choose the smaller wire just purely because it's less wire. And I think it'll work really well for what I want. Alright, so briefly I'm going to show you guys what I'm doing. I'm going to take this Kapton tape, I'm going to wrap it around the copper part here. And then I've got some regular red wire crimp junctions that I'm going to use for crimping everything together. I've got thermistors here, I forgot the part number. And then I've got some PTFE tubing. I don't know if this is actually shrink wrap tubing, but it's a PTFE tubing. I got it from a guy's house that had a bunch of stuff I brought home one time. This is some PTFE coated, copper coated wire, or silver copper coated wire. I'm just using it because it's PTFE coated here for thermal protection. And then I'm going to basically take this stuff in cotton swabs, and I'm going to put this on here on top of the tape and mix it all together and just go through the whole thing and sort of layer this wire. I think I'm going to go ahead and go with 2.25 amps, which gives me somewhere around like 28.5 watts of power, and it's going to be directly over the center of this guy, so I think that'll be plenty of temperature here. The thermistors I'll add later, but I had them out. And then I'm going to take, yeah, that's what I'm going to do. I have no idea how well this is going to go. This is a trial and error experiment. Alright, so I took one of these red butt splice connectors and I cut the inside out, and it's a full barrel, which is nice. It's not a half rolled crimp thing. And then I cut that into 2 pieces, and you have to use these to crimp the main wire to your heating element, because if you use solder it'll just melt off. So you can't use solder. So we're gonna do it this way. Just thought I'd show you a close-up. I also taped up this guy with Kapton tape all the way around it, 400 degrees Celsius working temperature. Thank you, Steve, on the interwebs, streaming live for the data while I was working. So there you go. Now we'll start this process. Alright guys, so to make this splice, I thought I'd get a pretty good close-up. I've wrapped the heating element wire around the wire I want to crimp. I'm going to slide this over, and I'm going to nicely crimp that on there with a pair of jewelry crimp. Actually, these are a pair of jewelry clamps, but any crimps, even a pair of pliers should do good as long as you can crush it good. Alright, and that's that. So, it ain't the best I've ever seen in my life, but it sure ain't letting go. Alright guys, I was lucky enough that wire is about 10.5 inches long, and it wraps around there just right. I put a piece of PTFE plastic between the wire going under to the bottom and the wire going to the top. And I'm just going to coat this entire thing really, really well with the with this stuff, and then put tape, Kapton tape on the outside. And once it's set up and hard, I think it'll be fine. It comes up way higher than I really like, but you know what? We're gonna try it. Alright, for all intensive purposes, this is what we've got going on. Now I'm going to actually drill a hole right here in this little block straight down, and that's where I'm going to put my thermistor, so I can still grab it on the sides to unscrew the tip. I think this is going to work alright. Alright, well, I've managed to drill a hole down there, and I drilled it just right into the end of the tungsten nozzle here. So I'll put a tiny little bit of this compound in there when I put this together. That'll work out well. Thermistor fits right in that hole. Alright, so what I did is I ended up taking two sizes of PTFE tubing, the small one and the big one, and they almost fit inside each other to the point where I could fit a wire and the one PTFE tubing in there, so I've got one isolated from the other like that, and then it just comes down and it's right at the end. So that will just stick in here. It'll just be taped on there, and then I can do my wire junctions up here. And this PTFE tubing is pretty stiff, so it won't allow for anything dramatic to happen, I hope. Okay guys, so that's really it. I did go ahead and put some of that compound in the end down there. I think it's got pretty good thermal conductivity, so it should be pretty good. I could have put something else in there like, oh, I forgot what it is, heat compound. But I'm going to basically heat shrink all these together up here, right in this section, so that all these are sort of affixed. Actually, yeah, because I'm going to attach the wires here physically up here so nothing else moves. So I'm going to go heat shrink this, put a couple more layers of Kapton tape here, but this will allow me to still take the end off, and actually I can unscrew the heating element from there. It's all a isolated thing. We'll see how that works. I have no idea. Trial and error. Alright everybody, so here we are. I've taken these two pieces off. Not necessary to show you the final heating element. So this is the heating element. Thermistor is right in this block right here, which is exactly where we want it to be, deep down inside there. Heat shrunk everything so it doesn't really move around. I can still unthread it and put it on a new unit, and then I've soldered on the ends. These ends right here are actually really nice. They're RC connectors. I need to find out what brand and type they are, because I want to order some more for the new OSD printer. I love these. And then I'm using an old connector like this for the thermistor. I don't particularly like this style because I've had lots of issues with corrosion. So the last step, besides testing this just like this with nothing else connected to make sure it gets up to temp and holds a steady temp without anything bad happening. The other thing is I'm going to use PTFE tape. I'm going to wrap them on here when I assemble this, and that'll allow all the plastic not to squeeze out the wrong places. However, you want to make sure you don't get any wrapped in here because it'll try to go out the nozzle and clog it up. Let's go test this thing, see how it works. Okay, so I've connected these up to their appropriate positions. We're reading 25 degrees right now with this little unit as is. So we're going to turn this on and we're going to just see what temperature. We're going to go up to 100. So we're heating up. Look how fast they're heating up. It's making a few noises. You can hear it. That's from the plastic stuff setting. I don't see any smoke. So now we need to really kind of tune the PID because that sucker heated up fast, but it's just the block. Alright, well, I'm going to let it cure for a while at 100 and go from there. Alright, I ended up putting the Hotend on there, cranking it up a little at a time. It's always a little scary when you do this the first time because we'll bring it up to 200 because it sort of wants to make some smoke and things. See it? You can see it in the light. I can see it coming off. So that first time cranking it up always is a concern, but gotta do it. See if we can push some filament through it. It's only at 200, but look at that. I always like to see what it looks like when you pull it back out. Looks fine. There's no big clump at the end, it's small all the way through. That's ideal in my opinion. That means when you do retraction, it's not trying to pull out a bunch of stuff up high. So now what I'm going to do, I'll push this in here. And I'm going to let it sit for a couple of seconds. As if it was in there while it was hot. And then we're going to push it again and make sure it still goes. Yeah, pretty good. Again, we're only at 200. So I'm not maxing this guy out. Oh yeah, see? Pulled it right there at the end. And there's not too much up here that's hot. You can actually still see the ribs. So that's a really, really good thing. So because I have that PTFE liner in there, it does really good with that. This is good. I'm excited. I need to fix this for a long time. The only real reason I'm doing this is because I really do like this tungsten nozzle, and it has to be threaded into a block. So this is the old block. This is a Chinese block with a like 10-watt heater or something, and oh, I hate it. I don't like this type at all. It drives me nuts that they even designed them this way. I don't know why, if you would want even heating, you wouldn't put a circular heating block on your Hotend. It doesn't make sense why you wouldn't do it this way. So I think it's ready to start printing. Yeah, we gotta do a few more things though. Okay, so the preliminary tests seem to be really good. I'm very happy with this thus far. Until we really test with it, we won't know. Now there's one thing that I'm gonna fix before I go on, and that is, you see how there's some slop in here? That's because we drilled a 5mm hole for a 4mm tube. That's because we had to thread this with a the proper size bolt. Now I could have not drilled all the way through, but actually I'm gonna make a little insert for this right here. This little bit of slop may not matter, but when this PTFE gets hot, it gets a little soft, and so if you try to push something through here while this is soft, it could kink inside of here, which could cause a serious issue. Now the other problem is if it is that soft and you try to push something into it, it has the potential of trying to slide forward and actually clogging the end of this. So the solution for that is to create a little insert that goes in here that's made out of probably aluminum. That's what I'm going to use anyway. I could even use this plastic now that I think about it. Might be a better option. But basically I'm going to make an insert so that I can thread something into this PTFE tubing and allow it to be held in position so it can't be pushed down. Okay, so you're constantly not allowing, by a pinch point here, not allowing that to be pushed into the hot end. I think that might be causing me some issues on the other stuff. This stuff gets pretty soft when it's hot. So I think I'm going to do that, and that'll be the last thing I need to do for this. Okay, because I don't have the time, I'm not going to put that extra piece in the back right now. I'll do it another day. But this, really quickly, this is a washer that I threaded a while back for some other project. Actually, it was a different hot end I was trying to build. Anyway, that's an extra thread stopper. But basically, I'm going to take this PTFE tape and just wrap a couple of wraps on here, so when I put it in the heating element and stuff, that the plastic doesn't bleed past the threads, because it will, and it'll squeeze out everywhere. So that's how I get around with that, and I'm not worried about putting a set screw in the side of here. If that nozzle moves, it's because I don't have it tight enough, because those two butt up against each other and they lock. So anyway, we're going to do that now. Alright, boys and girls, I think we've successfully done it. I am just testing how fast the print can run and how fast the plastic can flow, and it is holding a really good steady temperature, where before it would swing like almost 10 or 12 or 15 degrees. It was terrible. It's giving me all kinds of fits. So now we'll adjust the bed height and go from there. I'm happy with that. And yeah, this was all on the live stream. For those of you who missed that, come back and watch it. Alright, well, everything was going fairly smoothly, but if you can see, if this camera will focus, there's some stuff oozing out everywhere, and actually it's oozing out so much that it's kind of making messes, and that's a potential problem. It's actually coming out of the thermistor hole, which is a big problem, and it's coming out of here. I didn't put enough Teflon tape around there, so we'll fix that. I think I'm going to pull that thermistor out and try to seal that hole a little better before I put it back in. Just barely drilled it too far, and that's a serious issue. Well, even with the adjustments, this sucker is really running pretty good. I got it cranked up pretty good compared to my normal, just because I like to let it run a little slower, but it seems to be running just fine at this speed, actually. Usually the limitation is how much plastic can push out, but it seems to be alright. Now I gotta worry about that oozing. I capped it off, but I don't know. I think it's still leaking out of the bottom. I gotta let it run for a while, find out. Oh, things are looking good. That's a good layer. It's running pretty fast too. So success. I went ahead and put more tape on that bottom nozzle, that one, and I need to put a tiny bit more. But I ran this even faster than this, and it's working really well. Heats up really, really fast, and so far so good. I went ahead and, like I said, put a bunch of stuff on this side to keep it from coming out. It's okay. I filled the hole with Teflon tape and then packed the thermistor in there and then coated it with the the gasket making stuff, or the crack sealer for exhaust systems. That stuff works really well. I'm pleasantly happy with that. I'll be using it in the future. Okay, so let me show you an example of kind of the problems I was having. So here is a ring. You can actually see the top here, how it's falling apart. There were a bunch of these that didn't even make it. So the ones that didn't make it, they just kept grinding the filament, or the motor would start skipping, because actually that thing grinds or gets into that filament pretty good. So this is really hard to see, but you can clearly see the difference in the print. Bad thing is the color here is hard to see on the background. There you go. You can almost see it's too hot. I almost had to get it too hot to make sure it would stay right, but anyway, and then the inside, you can see the inside's really so much better. And then here's some of these formers for the rodent coil. You can see the back and how bad they are. That black contrast is hard to see on this camera, but here's a new one printed on the with the new Hotend. The seams, everything, just a lot better. Alright, well, I'm satisfied with what I learned, but there is a couple things I need to talk about. So here on my original first Hotend build, I guess not really the first Hotend, but the first heating element, everything's compact. It's the same amount of wire, it's the same size wire, and you can probably see it right there. Okay, and I used a different type. I used cement that you use to put on seals for ovens, like high temperature stoves and stuff, and that stuff's alright, but I kind of like the other stuff better. Hardens better, it's easy to work with, it's not as messy. But the Hotend, or the nozzle I should say, was basically recessed right next to the heating element. Now on the other one, it's really long. I wrapped one layer all the way through. This one I wrapped 3 layers thick, same amount of wire, same everything, same current and everything. So I actually really like this better, and I'll have to redesign that other one eventually, because what's happening is a lot of the heat dissipates up into the top, and that's an issue. So what I noticed is, because the heating element goes so far up into the top there, that the tip wasn't necessarily ready to go from cold to cold. If it's cooling down and restarting a print, it's fine. But as far as what I did earlier is I tried to get it to come out when the temperature said it was hot, but it didn't work because the nozzle, the very tip, wasn't warmed up quite yet. So just something to remember, something to think about. I will be doing that slightly different in the future. Yeah, thumbs up. Have a good day. I think I'm gonna let this go one more time on there. I want to see it lay down. It looks really nice. The outside layer is slightly slower, as you can see. That gives me a nice surface finish, but printing nice and fast on the inside. Faster than I normally print. Normally I print things pretty slow. Oh, and earlier, a lot of those prints were on a much slower speed to get them to turn out. Couldn't run this thing fast for nothing. Alright, let's see if we can catch it over here. Alright, peace out, bye.